A simple harmonic oscillator with an amplitude of 0.470 meters has a speed of 2.15 meters per second when it is 0.23 meters from equilibrium. What is its period? What is its position when it has a velocity of 1.1 meters per second? What is its acceleration when it is at x equals negative 0.37? Oh dear, oh dear. Okay, so we know that the amplitude is 0.470 meters, right? And when it's, we know that when it's at a position of x is 0.230, the speed is 2.15 meters per second. So I can answer that first question. What is its period? All right, I'm going to use this formula. What is it? Plus or minus omega square root of x naught squared minus x squared, right? And I'm going to solve that for omega, right? So 2.15 is equal to, I'm just going to dispense with the plus or minus. I'm just going to throw the omega in there, and then square root of 0.47 squared minus 0.23 squared. And I can do this. So let's see. So 2.15 divided by the square root of 0.47 squared minus 0.23 squared. Don't forget to square these things, right? And I get 5.245. Radians per second, right? And then the second step is omega is what, 2 pi over t, right? So 5.245 is 2 pi over t. So therefore t is 2 pi divided by 5.245. So let's figure this out. I could do this. 2 pi divided by the answer I just got. And I get that the period is 1.1978 seconds. So that's our first answer, right? Okay. And I think like on the assessment, it's only going to ask you one of these. I just threw a bunch in here because we ought to be able to do it, right? Okay. So now it says, what is its position when it has a velocity of 1.10 meters per second? I'm going to use this value, but I have to erase the screen. So I'll use that value, and then I'll use this value. And you'll see, I'll use the same equation. So let's do that. I'm going to erase the screen here. Boom. Okay. So we have, from the previous problem, right, we've got omega is 5.24546, right? We've got that the amplitude is 0.47, right? And now we know that the velocity is 1.1. And it's asking us what is our position, right? So let's do that, right? So V is plus or minus omega square root of, right? So now we can plug it in. So 1.10 meters per second is omega that we already figured out, right? .24546, right? Square root of 0.47 squared minus x squared. The kids have a hard time with this, right? So let's math this carefully, right? The next step is 1.10 over 5.24546, and then you want to square that, right? And that's going to equal 0.47 squared minus x squared. So I did two steps at once. I divided that, then I squared both sides to get rid of the radical, right? You always want to get rid of the radical. Okay, and then I'm going to solve this for what x squared is, right? So 0.47 squared minus the quantity 1.1 divided by omega squared. I'm getting that x squared is 0.1769. So I'm going to square root both sides. And I get that x is equal to 0.4206 meters, which would be 0.421 meters, right? Okay, so so that's not so hard, right? You just have to carefully do the math, and kids sometimes struggle with this math. So do it step by step. Don't do anything that would give your math teacher a sharp abdominal pain, right? And then what is its acceleration when it is at x equals that? Well, I'm going to use this omega that we figured out in the first part of the problem, and I'm going to use that x, and that's all I need to do, okay? So I'm going to erase the board. So omega from the very first question, what is its period? We figured out omega was 5 point, I got to find it here. There it is. 5.24546 radians per second, right? We know that the x is negative 0.370 meters, right? And I'll just use this. A is the opposite of omega squared x, the opposite of 5.24546 squared, right? Okay, times negative 0.37. So this will be a positive number, right? Because it's negative and a negative. This like it's not opposite of omega squared, right? That'd be stupid because it would never ever matter that you put the minus sign there. Okay, it's this. Okay, so opposite of that number. This is the case where the TI actually calculates it that way, right? Okay, times negative 0.37. And I'm getting that the acceleration is positive 10.18 meters per second squared. Ta-da! There it is. All the parts. We did this, we did this, we did this.